Hello, and welcome. I'm Matt, and today, we're embarking on a journey across billions of miles, out to the gas giants and the edge of our solar system. We can't go ourselves, so we'll travel with our robotic pioneers, the probes that braved the cosmic dark. Today we celebrate the legendary machines, Pioneers, Voyagers, Galileo, Cassini, and Huygens. These aren't just metal, they're our eyes and ears in the unknown, sending back images and data from worlds we once only dreamed of. Their stories are about daring engineering and humanity's relentless curiosity. Buckle up. We're about to honor the little robots that could, and the epic discoveries they made. This is a story of cosmic wonder, danger, and even a little humor. Because when you send million-dollar robots into the void, you need a sense of humor. Let's begin. Our story starts with Pioneer 10, the first spacecraft to brave the asteroid belt and approach Jupiter. In 1972, the asteroid belt was a feared region. Some thought it was a deadly minefield that would destroy any probe. But NASA took the risk, sending Pioneer 10 through this unknown territory. For 7 tense months, every signal was a victory, proof our explorer survived. Pioneer 10's detectors revealed the truth. The asteroid belt was mostly empty space, not a cosmic shooting gallery. The probe's safe passage shattered old fears and opened the way for future missions. It proved the path to the outer planets was open. Without Pioneer 10's daring, the grand tours of Voyager, Galileo, and Cassini might never have happened. On February 15, 1973, Pioneer 10 emerged from the belt, unscathed and triumphant. It had faced the unknown and won. The greatest gas giant, Jupiter, was now in its sights. This single act of courage changed the course of space exploration. The road to the gas giants was open. Pioneer 10 was our scout, and it showed us the way. The adventure was just beginning. With the asteroid belt behind, Pioneer 10 and its twin, Pioneer 11, became our first emissaries to Jupiter and Saturn. In December 1973, Pioneer 10 flew past Jupiter, sending back humanity's first close-up images of the Great Red Spot, a massive centuries-old storm. It also discovered Jupiter's magnetic field was far stronger than expected, nearly frying the probe's electronics. A year later, Pioneer 11 used Jupiter's gravity to slingshot toward Saturn. In 1979, Pioneer 11 became the first spacecraft to visit Saturn, revealing the rings as a complex system of ringlets and discovering the faint F ring. It bravely flew beneath the rings, scouting a safe path for the Voyagers. The Pioneers were more than machines. They were pathfinders, breaking records and opening the outer solar system. They gave us our first taste of the wonders and dangers beyond Mars. Their legacy: they opened the door for a new generation of explorers. The age of planetary exploration had truly begun. The Pioneers' journey was over, but the main expedition was about to launch. The Voyagers were ready. If the Pioneers were scouts, the Voyagers were the main event. Launched in 1977, Voyager 1 and 2 were built to last, taking advantage of a rare planetary alignment. Each probe was packed with instruments and powered by nuclear energy for the long, cold journey. But they carried more than science. They carried the golden record, a message to the cosmos with sounds and images from Earth, greetings in 55 languages, music, and the sounds of our planet, an optimistic gesture to any distant finders. Carl Sagan called it a hopeful symbol of life on Earth. The Voyagers were more than machines. They were ambassadors and time capsules, carrying our story beyond the solar system. Their mission: to explore the farthest planets and, eventually, interstellar space. As they set off, they redefined what was possible in space exploration. The cosmic road trip was underway. The greatest adventure in robotic exploration had begun. The universe was about to get a lot bigger, and so were our dreams. The genius of the Voyager mission was its timing. 1977's rare planetary alignment allowed a single probe to visit Jupiter, Saturn, Uranus, and Neptune. Using gravity assists, the Voyagers could slingshot from planet to planet, gaining speed without extra fuel. Voyager 2 launched first, set to visit all 4 giants. Voyager 1 followed, aiming for the best look at Jupiter, Saturn, and especially Titan. At Jupiter, the Voyagers sent back stunning images and discovered active volcanoes on Io, the first seen beyond Earth. The Galilean moons became dynamic worlds, not just points of light. At Saturn, the Voyagers revealed the ring's intricate structure and studied its diverse moons. Voyager 1's close pass by Titan sent it out of the planetary plane, ending its grand tour, but giving us a glimpse of a world with a thick atmosphere. Voyager 2 pressed on, heading for the ice giants. The grand tour was only half over. One probe was bound for interstellar space. The other ventured deeper into the unknown. Each encounter made the solar system bigger and stranger. The Voyager's discoveries transformed our understanding of the outer planets. The journey was far from over. The next stops, Uranus and Neptune. The edge of the solar system awaited. With Voyager 1 gone, Voyager 2 became our only emissary to Uranus and Neptune, mysterious worlds barely seen from Earth. In 1986, Voyager 2 reached Uranus, where engineers used image motion compensation to capture sharp photos in the dim light. Uranus appeared calm, but Voyager 2 found it was tipped on its side, with bizarre seasons and hidden rings and moons. In 1989, Voyager 2 arrived at Neptune, discovering the Great Dark Spot and the fastest winds in the solar system. Its flyby of Triton revealed cryovolcanoes and a geologically active, frozen world. With Neptune complete, Voyager 2's planetary mission ended. 4 planets, dozens of moons, and 12 years of discovery. It was the most successful exploration mission in history. Now, both Voyagers were headed for the stars, their grand tour complete. They left behind a legacy of discovery and wonder. The outer solar system was no longer a mystery. Humanity had reached the edge. The lonely travelers pressed on. Their signals still whisper from the dark. Flybys gave us snapshots, but we wanted more, so we sent Galileo to orbit Jupiter. Launched in 1989, Galileo was designed for a long-term study of Jupiter and its moons. The mission nearly failed when its main antenna jammed, but engineers improvised, inventing new data compression to save the mission. Galileo arrived in 1995, first dropping a probe into Jupiter's atmosphere for direct measurements before being vaporized. For 8 years, Galileo orbited Jupiter, making 35 close passes and revealing the planet's storms and dynamic moons. Its greatest legacy, confirming a vast ocean beneath Europa's icy shell, making it a prime target in the search for life. Galileo also found evidence for oceans on Ganymede and Callisto, and revealed Io's volcanic fury. In 2003, with fuel low, Galileo was sent into Jupiter to avoid contaminating Europa. It was a final act of planetary protection. Galileo's mission changed how we see the Jovian system. It proved the value of sticking around. The age of orbiters had begun. Cassini did for Saturn what Galileo did for Jupiter, on an epic scale. A joint NASA-ESA Italian mission, Cassini was the largest interplanetary probe ever built. Launched in 1997, it took 7 years and multiple gravity assists to reach Saturn. In 2004, Cassini became the first Saturn orbiter, sending back over 450,000 images. It revealed the ring's dynamic structure, moonlets, and vertical features. Cassini's radar mapped Titan's surface, showing rivers and lakes of methane and ethane. Its most profound discovery, Enceladus's plumes, evidence of a subsurface ocean with the ingredients for life. Cassini watched Saturn's seasons, storms, and sunlight glinting off Titan's lakes. In 2017, with fuel gone, Cassini dove between Saturn and its rings before plunging into the planet, a spectacular finale. Cassini gave us a backstage pass to Saturn's wonders. Its discoveries changed our view of the outer solar system. The mission ended, but its legacy endures. Bolted to Cassini was Huygens, a European-built lander destined for Titan, Saturn's largest moon. In January 2005, Huygens plunged through Titan's thick atmosphere, drifting down by parachute for over 2 hours. Its instruments measured temperature, pressure, and chemistry, while cameras revealed a landscape shaped by liquid. Huygens landed with a gentle thud in a dry riverbed, surrounded by ice pebbles smoothed by methane flows. For 72 minutes, it sent back data and images, the first and only landing in the outer solar system. Titan proved to be eerily Earth-like, with weather, seasons, and liquid on its surface, though made of methane, not water. Huygens gave us a ground-level view of this alien world. Its landing was a monumental achievement, a postcard from the strangest shoreline in the solar system. The mission showed that even in the coldest, darkest places, there's wonder and complexity. Huygens' name honors Christian Huygens, Titan's discoverer. The probe's brief life changed our understanding of distant worlds. Titan's secrets are only beginning to be revealed. The search for life continues. Our tour ends, but the journey doesn't. From the pioneers to the voyagers, Galileo, Cassini, and Huygens, these robotic explorers have rewritten our understanding of the cosmos. They are our avatars, braving the unknown and sending back discoveries that inspire us all. These missions are more than science. They're a testament to human curiosity and the drive to explore. The story isn't over. New missions and new horizons await. If you want to keep exploring, subscribe and join our community. Curiosity is our greatest engine. Keep looking up.